Lesson 5-9 Arithmetic Sequences, and in this lesson you learn to find the terms of arithmetic sequences and to represent a sequence algebraically. Let's take a look at this activity. Have you ever seen a flash of lightning and heard the roll of thunder and wondered how far away it was? We can generate a table to estimate the distance to a lightning bolt for which you heard the thunder. Sound travels approximately 1,100 feet or 1/5 of a mile per second. For every second that passes, the sound waves of the thunder travel an additional 1,100 feet. So we have this table, okay, and we need to fill in this table. So distance, if the time is 0, distance is 0, and obviously the distance in miles will also be 0, okay. Time in seconds is 1, distance in feet is 1,100, and distance in miles 1/5 of a mile. 2 seconds, 2,200 feet, 2/5 of a mile, okay. And then using a calculator, okay, you have 3 seconds, and then the number of feet would be, okay, 3,300, and that would be 3/5 of a mile. So you see a pattern emerging, and 4th second, 4,400 feet, 4/5 of a mile, 5 seconds, 5,500 feet, 1 mile, 6,600, and 1 1/5 of a mile. Okay, so if after completing the table, we can answer these 3 questions. How far away is the flash of lightning if the thunderclap takes 4 seconds to reach the observer? So from what our table is indicating, it's 4,400 feet, or about 4/5 of a mile. What pattern you see on the table? Okay, the pattern that you see here is the distance increases by 1,100 feet, or 1/5 of a mile, which are with each second. And write a rule for finding the next number in the pattern. So that's easy enough. We simply add 1,100 feet, or 1/5 of a mile, to the previous distance. Okay, so in this case, we take a look at our lesson. A branch in math called discrete mathematics deals with topics like logic and statistics, like the one in the last lesson too. One topic of discrete mathematics is sequences. A sequence is a list of numbers in a certain order, such as 0, 1, 2, 3, or 2, 4, 6, 8. Each number in the sequence is called a term. So 0 is a term, 1 is a term, 2 is a term, and so on and so forth. A sequence, like the distances for thunder, where the difference between any 2 consecutive terms is the same, is called an arithmetic sequence. So it's just it just defined it for you what an arithmetic sequence is. So any 2 consecutive terms is the same, okay, and the difference between them, okay, between any 2 consecutive terms is the same, is called an arithmetic sequence, okay, and the difference is called the common difference. So if we were to define an arithmetic sequence, this is how we define it. An arithmetic sequence is a sequence in which the difference between any 2 consecutive terms is the same. Okay, and we call that difference the common difference. Okay, let's take a look at example number 1 and see how this works. Example number 1, state whether each sequence is arithmetic, then write the next 3 terms for each sequence. We examine 1.25, 1.45, 1.65, 1.85, and 2.05. Okay, and the first things first, find the difference between the consecutive terms in the sequence. Okay, if you find the difference, 1.45 minus 1.25, 1.65 minus 1.45, 1.85 minus 1.65, and 2.05 minus 1.85, we know that that difference would be 0.2. Okay, so with that said, you have a common difference because the difference between those 2 sequences are all the same. Since the difference between any 2 consecutive terms is the same, the sequence is said to be arithmetic. And if we continue our sequence to find the next three terms, okay, we know that after adding 0.2 every single time, we'll end up with these next three terms. Okay, 2.25, 2.45, and 2.65. Okay, so those are the next three terms. Letter B, 1, 3, 7, 13, 21. Okay, and if you notice, there is no common difference because 3 minus 1 is 2, 7 minus 3 is 4, 13 minus 7 is 6, 21 minus 13 is 8. There is no common difference. Since there is no common difference, the sequence is not arithmetic. But it does not mean that even if it's not arithmetic, okay, it is still considered to be a sequence. So notice that the differences are in the pattern 2, 4, 6, 8. So the next three differences will be 10, 12, and 14. Therefore, we can now predict the next three terms. So the next three terms are 21 plus 10, or 31, 31 plus 12, or 43, and 43 plus 14, or 57. So those are the next three terms. Finally, letter C, 13, 8, 3, negative 2, and negative 7. Okay, and this, we copy down the numbers and we look to see that it will have a common difference because 8 minus 13 is negative 5, 3 minus 8 is negative 5, negative 2 minus 3 is negative 5, negative 7 minus 2 is negative 5. Okay? So with that said, we can now find the next three terms for this one. So that means, what is negative 7 plus negative 5? That will give you negative 12, negative 17, and negative 22. So, the common difference is negative 5. The sequence is said to be arithmetic, and these are the three terms that will follow: negative 12, negative 17, and negative 22. Okay? And let's take a look at the last aspect of this lesson. If we know any term of an arithmetic sequence and the common difference, we can list the terms of the sequence. Let's consider the sequence: 3, 7, 11, 15, 19, and 23. This is said to be an arithmetic sequence because 7 minus 3 is 4, 11 minus 7 is 4, and so on and so forth. It has a common difference. We can write an expression that represents any term in the sequence. The first term is 3. Okay? We call that first term A. The common difference between the terms is 4. Call the common difference D, and study this pattern. So if the first term is A, okay, and that's our 3 right there, and the second term is D, okay, which is our 4, the common difference, the result would be the second term, which would be 7. Okay, that's our second term. And if we continue that pattern, the third term would be A plus the common difference plus the common difference would give us 11. Okay, so basically A plus D is the same as A plus 2D, or if we look at our pattern here, it's simply 3 times 2 times 4, which is gives us 11, which makes our third term. And if we analyze our fourth term, this is now A plus D plus D plus D, or A plus 3D. And if we substitute the values from our example, we still end up with our fourth term, which is still 15. Okay? So if this continues, and instead of a fourth term, we look at the nth term. Okay? So the nth term would be A plus n minus 1 times D. Okay? So that would be n minus 1 times D if we follow that pattern. Okay? So we now found our formula to finding an arithmetic sequence. And you need to memorize this for the test. Okay? So in this case, because n represents any term, you can use the expression a plus n minus 1 in parentheses multiplied by d to find any term in the sequence. Okay, so how do we use this particular formula? Let's take a look at this example. In 1999, the first class postage rates were raised to 33 cents for the first ounce and 22 cents for each additional ounce. A chart showing the postage for weights up to 6 ounces is shown below. What was the cost for a 10-ounce letter? So let's start off with the weight in ounces. You have 1 ounce, 33 cents, 2 ounces, 55, 3 ounces, 77, 4 ounces, 99, 5 ounces, 121, and 6 ounces, 143 cents. It's asking what was the cost for the 10-ounce letter. So how do we approach this problem? Okay, again, we can use the formula to find the 10th term, because basically what it's asking, what is the 10th term for this sequence? Okay, so use the expression a plus quantity n minus 1 plus quantity d to find the 10th term of the postage sequence. Okay, and doing so, okay, the first term we represent as a is equal to 33. That's our first term. The common difference is 22, because every time we do 55 minus 23, 75 minus 55, and so on and so forth, it'll be 22. Since we are looking for the 10th term, n is equal to 10. Okay, let's substitute these values to our formula. We now end up with 33 plus 10 minus 1 times 22. Simplifying it further now, we end up with 33 plus 9 times 22. Okay, 9 times 22 becomes now 33 plus 198, which is equal to 221. The 10th term for the sequence is 231 using our formula. So, a 10-ounce letter would cost $2.31. Okay? And that's the end of this lesson and the end of this chapter. Thank you for watching.